Okay, this week we will be continuing with Chapter 3, the flow of fresh water. We will be moving on to Section 3, which is called Water Underground. In this section we're going to see all of the ways that water can be found underground, can be used underground, and how it can affect the surface through its underground activities. This week we will be looking at the objectives one at a time. In class, each group had one objective assigned. Here, we will take a closer look at each of those objectives. Starting with objective number 1. Identify the location of the water table. Okay, the water table. As we can see down here, it's the first vocab word in the section. But first we need a little context to understand what exactly this means. First off, groundwater. Groundwater is, just as the name says, water in the ground. So, when we look at the surface, we see rivers and lakes that have water, but there's also water underground. And this water that is underground is actually combined with the rocks and the dirt, and it's just there. We can't really see it, but we do use it. So, the water table is the boundary of two zones. So, we look up here and we see zone of aeration, zone of saturation. As I stand here on the surface, I'm on the surface. If I could see straight down, I would immediately enter this, called the zone of aeration. This means that in this area here, the ground is not saturated with water. That is to say, if I dig up some dirt, I'm going to get dirt. It might be a little moist, but it won't be saturated with water. However, if I keep going down, I will come to a point that is called the boundary between the zone of saturation and the zone of aeration. This is where the water table begins. So, what's happening here is that as water falls on the surface, it slowly infiltrates down into the ground until it all builds up here. Now, it can't keep going down any farther because of the bedrock, as we learned in Chapter 2. So, it starts to pile up, completely saturated, until it gets to the point where there isn't any more water. Now, this zone of saturation usually isn't right next to the surface. Otherwise, it would just wash everything away, and it would be a lake or a river. So, the water table is the section of ground, underground, that is completely saturated with water. Okay. Now that we know that there is a saturated section of water underground, we can move on to objective number 2, which is describe an aquifer. An aquifer is the next vocab word, as we see here. It is defined in the book as a rock layer that stores groundwater and allows the flow of groundwater. This is an aquifer. Aquifers are described by their ability to hold water and its ability to allow water to pass freely through it. So, what this is to say is that underground there are rocks that are completely saturated with water. Now this may seem a little counterintuitive because you know if you pour water on a rock, the water will run off the rock. It doesn't soak into the rock. But if we could look very closely at the rocks with a microscope that was very powerful, we could see that they are made up of particles. They are not completely solid like they seem to us. And these different structures mean that when they are completely encapsulated with water, they will behave differently. Now, the two important vocab words here are porosity and permeability. Now, porosity is the percentage of open space between individual rock particles. That is to say, the more open space there is between the particles, see more open space here than here, that means the rock can hold more water. Obviously, the water will fill in the open spaces. So, more open spaces, more porous, more water can be held in this rock. Now, permeability is a rock's ability to let water pass through it. So, what this means is the more channels there are through the particles, or the more routes the water has to choose from to get through, the more permeable the rock is. Now, it may seem intuitive to say that a more porous rock will also be more permeable. However, this is not always the case. Some rocks are very porous, but not permeable. That is to say, they are porous, but impermeable. Impermeable means that they do not let water pass through. Clay is a good example of something that is impermeable. On the next page, we can see a map of the United States that has all of the aquifers in this bluish, greenish, celeste kind of color. So as you see, the United States is really big, geographically speaking. This is like 5,000 kilometers across. So these aquifers are really big. There are enormous amounts of water locked up in the rock underground. And we use them. We tap them with wells. Cities use them. The water that comes to our houses comes from these aquifers. Groundwater is the water that we use in our houses, in our places of work, here in school. It's all coming from these aquifers. So aquifers are kind of important. Okay, now we can remember that erosion is the moving of particles of soil caused either by gravity, wind, or water. So now that we know that water is flowing underground, it's reasonable to conclude that erosion will also happen underground, which leads us to objective number 3, explain underground erosion. So as we can see here, we have a picture of a cave. Caves are the result of underground erosion. This is where water used to flow through a part of the bedrock that was not as solid as the others. If you remember from chapter 2, differential weathering is when some parts of the rock weather faster than others. This is also what can happen underground. The rock underground can be more solid in some places and less solid in others, allowing the flowing water to little by little carve out paths. This is where caves come from. So, if anyone has ever been in a cave is the result of underground erosion from flowing water. So you can see here, deposition will also occur. Deposition is when the flowing water leaves little particles behind. So you can see we have stalactites and stalagmites. Two words that sound very similar. They are little spikes that form in the caves. The stalactites come from the top, pointing down, and the stalagmites start from the bottom and point up. You should know the difference between the two. Another result of underground erosion can be that an entire section of the underground structure of soil will be washed away until finally the surface just collapses. This is called a sinkhole, and they happen more often than maybe you would realize. You can see here part of this house, it all just fell down into this hole in the ground that was not there. So sinkholes are a real problem because you never really know where they're going to happen. As geologists, we can study the surrounding underwater flow. We can predict where they are likely to happen. There are some places in the world where they are very likely to happen, but this is also a result of what's below the surface being washed away by the process of erosion until finally it collapses. Objective number 4 states that we will compare and contrast different types of water pollution. In section 4, we will be learning about using water wisely. Now, we've all heard that we're supposed to use water wisely. Did you know that you are about 65% water? That means you need to continue drinking fresh, clean water to maintain that 65% of you. But there is a limited amount of fresh water on Earth. Only 3% of Earth's water is drinkable. The rest is in oceans. And of that 3% of the drinkable water, 3/4 of it is frozen at the poles. So that leaves us with a tiny percentage that we can actually use. So we have to be wise about how we use it. This section looks at pollution. Now, the vocab here is two different kinds of pollution. We have point source pollution and non-point source pollution. So pollution that comes from one specific site is called point source pollution. So if there is a leak in a pipe somewhere, like a sewer line, or if there is a factory that is illegally dumping its waste in the river, that is point source. It comes from one well-defined point or one source that can be identified. Point source pollution is easier to fix because you can find where it's coming from and stop it. The more difficult kind of pollution is non-point source pollution. This means that a little bit of pollution is entering the ecosystem from all different kinds of areas. So it would be like if the pollution was spread out in the air and was just gradually settling into the water, then there'd be no way to know where it was really coming from because it's coming from everywhere. So this is the main source of non-point source pollution are street cutters, fertilizers, eroded soils, things that are spread out over large distances. So Figure 1 shows us an example of non-point source pollution because it's spreading it out. That's pretty much the whole idea of the difference. One is localized, one is spread out. Now, once we understand what pollution in water is and the importance of water, we can create a plan for using water wisely, which is Objective 5. As we talk about health of a water system, we can see that there are a lot of different factors that go into it. There are many different gases and other compounds that are important to healthy water, but they need to be in the right levels. Too much of one can be bad, not enough of another can be bad. So, a good plan for wisely using water is to be monitoring what is happening to our water, to see if anything might be going wrong with it. Another way to use water wisely is to clean polluted water. This means that as water becomes polluted when we use it, there are processes which we can use to make the water new again. Most all cities do this. We have sewage treatment plants that treat the water and put cleaner water back into the environment. And there are also more localized forms of using water wisely at home. This is a septic tank. This treats the water that is used in a house over many years, and the water that comes in is not usable, but through this system, the water that is let out is more usable and does less damage to the environment. Now, another important thing to think about in water is where does water go? Some good information there. More information about how we use water. In class we may also be looking at some statistics on how water is consumed and what are actually the best ways to use water wisely. You may think that turning off your shower more quickly, turning off the spout when you're brushing your teeth more quickly would be the best way to do it, but as we will see in class, not wasting food is far and away the best way to conserve water because of the amount of water that goes into the creation of the food that we eat. So, surprisingly enough, agriculture is the biggest consumer of water in all of our systems. So it's something to think about. We'll look at it in class, and you will have something to present on this. So hopefully you guys are all ready, and I'll see you in class. Have a good day.